Welcome friends to my YouTube channel. Now on my last lecture I have discussed about the cylindrical coordinates, and we have seen that it is the extension of plane polar coordinate. Okay, and the relation between the position coordinates, between the cylindrical coordinates and the Cartesian coordinates, it's x equals to r cos theta, y equal to r sin theta, and z equal to z. And I also calculate the unit vectors, that is r cap, theta cap, z cap. Okay. Now in today's lecture I shall going to discuss a new coordinate system that is called spherical polar coordinate. Spherical polar coordinate. Okay. Now one thing must have to remember that this is a very suitable coordinate system in order to calculate the position vectors of a particle on the surface of a sphere. Okay, a convenient method. It is a very convenient method of finding the position vectors of a particle on the surface of a sphere. Okay, so this is a very convenient method of finding the position vectors of a particle on the surface of a sphere. So how we can represent it? At first we draw three axes. Take the vertical axis, this axis z, this y, and this x. Okay, suppose we take a particle at P, so this is the position vector of P with respect to O. Okay, now say this is R. So at first R is the position vectors of vector of the particle related to O. Now the angle that OP makes with the positive z direction is called theta. This is called zenith angle. This is called zenith angle. Okay, so it lies between always 0 to pi. Lies between 0 to pi. Okay, the line OP, the angle that the line OP makes with the positive direction of x, that is z, that is OZ, this angle is called zenith angle, and its value is theta, and it lies between 0 to pi. So if we call it z, okay, so it is clear that if we call it z, then we can write this is r cos theta. Simply we can write z equals to r cos theta. Now what is the vertical component of this line? This. Okay, fine. What is the vertical component of this line? That is this. So if this is r cos theta, this is r sin theta. So this is r sin theta. Okay, now give it a name, say q. Okay, give it a name, say r. Okay, give it a name, say s. So my OQ will be the vertical component of this line, that is r sin theta. Fine. Now another quantity that we have to introduce, the line OQ, the angle that the line OQ makes with the positive direction of x is called azimuthal angle phi. Okay, the angle between the positive direction of x-axis and the OQ, that is the vertical component of OZ. Okay, the angle between the positive direction of x and the vertical component of OZ, that is OQ, is phi, that is azimuthal angle. Phi is called azimuthal angle. and it always varies from 0 to 2 pi. Okay, it always varies from 0 to 2 pi. Fine. Now what we can write, this is angle phi. So what we can write, cos phi, that is this, that is say OR by OQ. Okay, so what will be my OR? My OR will be OQ cos phi. OQ cos phi. And what is OQ? That is R sin theta. That is simply R sin theta. Okay, that is OR. So if we call it X, then X equals to R sin theta cos phi. Now, so what would be the value of sin phi from this triangle? The value of sin phi from this triangle is RQ by OQ, and RQ by OQ. And what is OQ? OQ is R sin theta. Okay, so what will be my RQ? So if this is RQ, this is also equal to OS. That means R sin theta sin phi, and this is along y direction, that is we call it y. Okay, so this is the simple calculation of the coordinates. That is, first, R is the position vector of the particle relative to O. The angle that OP makes with the positive z axis is called zenith angle theta. So z equals to R cos theta. Fine. So the angle between the positive x direction, that is this, and the vertical component of z, okay, this is the horizontal component of z, so this is the vertical component of z. So this angle is known as the azimuthal angle that rotates within 0 to 2 pi, and by using these triangles we calculated the value of xy, since we know this is r sin theta, this is r cos theta, and this vertical component is r sin theta. Okay, so this is the calculation of the coordinates. Okay, so we can easily establish the relation between the Cartesian coordinates and the spherical polar coordinates. Okay, so what we can write, x we find r sin theta cos phi, y we find r sin theta sin phi, and z we find r cos theta. So let us check what will be the sum of x square plus y square plus z square. So this is simply r square sin square theta cos square phi plus r square sin square theta sin square phi plus r square cos square theta. So if we take r square sin square theta common, this is cos square phi plus sin square phi, this means 1. So this is simply r square sin square theta plus r square cos square theta. Okay, so this is simply r square. Okay, so this is the relation, that is in spherical polar coordinate. What we can write, r, this is simply x square plus y square plus z square to the power half. Okay, so we have find out the position vector. Okay, so in our today's lecture I shall give the basic introduction of spherical polar coordinates. So in my next class I shall going to discuss the unit vectors related to this coordinate and few other issues. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos. Okay, thank you.